Hi, I'm Mr. Moser, and welcome to this podcast on what is matter. So, what is matter? Well, we can kind of think about a bakery, and the bakery can tell us all about what matter is. What of all of this stuff in here is matter? In a bakery, they're going to have plates that they're going to serve the food on. As you walk in, you're going to smell all of the smells that are in there, the baking bread and jam. So is that matter? Well, yeah, all of that is matter. The bread is matter. Anything that you can feel and taste and see mostly, those are matter. But what isn't matter? Well, something that isn't matter here is this light. The light that's coming off of here, that is not matter. The heat that you feel off of it, also, heat coming off of the bulb. If you were to put your hand up to that light bulb, that is also not matter. And sound is not matter. Okay. So pure substances. Everything around us that's matter is made up of atoms. And so we have a picture down here of an atom. So everything is made up of these atoms. And we have all these different substances that are all around us, like water and like a diamond here. And what makes those up? Well, they're atoms, but there's more than one atom. If we have one atom that's all the same, every single atom inside of a substance, if it's all the same, then you have pure substances. And this diamond here, it's all made up of the exact same atoms. These are all made out of carbon atoms, if it's a pure diamond. And then we're going to have them all made out of the same thing. But water down here, water is made up of atoms, but atoms of different types. So we have hydrogen atoms and we have oxygen atoms that are inside of that water, making it up. So mixtures are just made up of like this fruit salad that you can see. This fruit salad here, it's tossed together. We've got apples and we've got some kiwis in there. Looks like some blueberries, blackberries, grapes. This is some mint in here, and this mixture of different substances here. We can pull out all the individual pieces of it there. I can reach in there and grab a hold of a blackberry and eat it there. So there's lots of different things there, and we have two different types of mixtures. We have heterogeneous mixtures, where we can actually see the individual particles. So like this sand here that you can see. The sand is made up of, you can see all the different little rock pieces in there. Some of them are maybe quartz, some of them may be feldspars. There are a whole bunch of different kinds of rocks in there, and they're just kind of mixed together. So that's a heterogeneous mixture. And then we have homogeneous mixtures. And a homogeneous mixture is like tea or coffee, where there's different things that are making it up. So in that tea that you can see there's or coffee or whatever it is, there is the water that makes it up, and then there's the tea leaves or the coffee beans that are ground up and mixed in there. But you can't see the individual particles that are inside of it. It's all mixed together, and it looks like it's all just kind of one thing there, but it's different. Okay, so like we said, everything is made up of elements out of these atoms. And, on the periodic table, we have 117 known atoms, elements, and we rank them, put them in different groups and families, and that's how we know of them today. 117 different kinds that are there. But that wasn't always the way it was. We didn't always know how many atoms we had, or how things were put together. In fact, the ancient Greeks, they used to think that there were only 4 elements. That there was fire and wind, water, and earth and air. That's what it is: earth, air, water, fire. And that everything that all the matter that's out there could be made up out of those 4 elements just by combining them together. So, for example, magma. Magma would be earth and fire mixed together to make magma. We obviously know that that's not the way it is. And this gentleman right here, his name is Robert Boyle, and he was a 17th century scientist who really started to think about elements in a really modern way. He came up with the first modern definition of what elements are. And he proposed that elements were substances that couldn't be broken down any further from what they already were. But the way we write down the different elements is they're either going to be 1 or 2 letters. The first letter is always capitalized, and so here we have carbon, and a capital C is the symbol for carbon. Li, capital L, and an I is for lithium, and carbon, and He for helium. So let's go back to the idea of an atom here. This is an atom right here, and this atom, like we said, everything is made up of these, and they are in size less than 1/1,000,000th of a millimeter across. So they're really, really small. They're so small that you can't even see them with a microscope. Our electron microscopes, you can't even see them because they're so small. And then, compounds are just made up of different atoms combined together. So in water, we have H2 and O. So that's hydrogen, 2 of them, 2 hydrogens, and 1 oxygen combined together. And these are just atoms that are combined together, and always in that ratio, and it makes up water. Okay, so then we have these mixtures versus compounds. So what is a mixture and what's a compound? Okay, well, mixtures, obviously we talked about when we saw the fruit salad. You can pick out the individual pieces out of there, and so if we have a grape inside of that fruit salad, we could pick out that individual grape and set it aside, or whatever is in that salad, and just kind of set it aside. So all of those pieces, they're mixed together, but they're not combined together. Compounds, they're made up of 1 or more elements, and they can't be separated by physical means. You have to do a chemical reaction in order to get them to separate. And so this is a picture of electrolysis going on. So we have water, and if we have this anode and cathode and put them together with a current running across them, we can separate the oxygen gas and the hydrogen gas out of the water. But it has to go through this chemical reaction. If we don't do the chemical reaction, you can't pull the hydrogen and the oxygen apart from each other in water. So solutions, they can be made up of liquids or gases or solids. So we have all kinds of different solutions. So we could have a gas in a gas solution, or we could have a gas in a liquid solution, or a gas in a solid solution. And some examples of those, so if we had a liquid, a gas in a liquid, that'd be like carbonated soda that we would have there. And if we had a liquid in a solid, that's like hydrogen bubbles inside of metal when you're doing a welding process, and it doesn't turn out quite right. You get porosity in there. It's just hydrogen that's dissolved in the metals. We could have gas in a liquid. Oh, sorry, we already talked about that. Gas in a gas. So like air, the air that we breathe, that's just a gas inside of a gas. And then we can also have these special kinds of solutions called alloys. And so these are metals, two different metals that are put together. Okay, so brass here. This is just brass off of bullets. These brass are alloys. And we have two different types of metals that are combined together and make this special kind of solution. And then also sterling silver is another example of an alloy. Okay, so colloids and suspensions are the last thing there that we need to talk about. We have a glass of milk here. Milk is a mixture of water, fats, and proteins, and you can't see the stuff that makes up the milk in there. You can't see the water or the fats or the proteins in there. Milk is a colloid. It's a heterogeneous mixture with larger particles, with these particles inside of it there, and they're in solution, but and they don't come out of solution. They don't settle out over time. Okay, so also there's colloids. The other types of colloids here. We have these types right here. We have a gel. Gel is a colloid. It has things inside of it that are large particles, but they won't come out of solution. We have emulsions. Milk is an emulsion, and we have aerosols. So aerosol is like solid or liquid particle that's suspended in a gas or a fog. So like fog or smoke is an example of that. We also have like sand. If we were to take sand and put it into a glass and mix it, those particles, while it's being mixed, while it's being churned around, they're big enough that they'll stay in suspension at that time. So this is what we call a suspension. But those particles are big enough that eventually they will fall out of solution. So yeah, and I hope that's helpful to you.